So yeah, so on that day we have seen tree set where we have seen something like it gets sorted. So I was just asking a question like internally tree set takes tree sorting to sort all the items in here, and I hope you know the tree set how it does, right? So let me give an heads up on tree set, and we'll just move on to maps after understanding this. Yeah. Okay, it's pretty simple actually. The internal arrangement of tree set sequencing is very simple. So it goes in this way. Let us say you have filled these items into tree set like 121, 5, right, 7, and some 100 and 160, right, some random numbers, right, and let us say some 250. Let us say these are a few elements which you have added into your set. Now internally, how does it arrange all these items so that it will be getting the sorted set as an output? Now how it gets is, so it will take the first item and it will keep it as a highest node. The first one will be the highest node, and then it move to the second element. Now this second element will be compared with this item, which is this number, which is 121. Now 5 is less than 121, then it will place that in the left side because 5 is less than 121. Now it will go to the next element, which is 7. Now it will again start from the first element, 121. 7 is less than 121, so it has to go to the left side, so it went to the left side. Now it is at 5. Now 7 will be compared with 5. Now 7 is greater than 5, which means 7 will be placed at right side of 5. Now again the next element, 100. 100 will be taken. Now 121. 100 is less than 121. Okay. It will get to left of 121. Now it will check with 5. Now 5, 100 is greater than 5. No, so it goes to right side. Now 7. 7 is less than 100, which is 100 is greater than 7, so 100 will be placed here. Now it goes to next item, which is 160. Now it goes here. Now 121. So 160 is greater than 121. So as there are no right nodes, so it will directly keep 160 as a direct child node of a 120. Now it goes to 250. Now again 250 is greater than 121, goes right. 250 is again greater than 160, goes to the right, which is 250 again. Now let us say you have got one more item, which is some 80, let us say, right, or let me take it as 6, not 80. Let me take it as 6 so that I can show you one more level. Now if it is 6 again, so 6 is less than 121, so goes to the left. Now 6 is greater than 5, right, so goes to the right. Now you can see here 6 is less than 7, so it comes to the left node, right. This is how it starts. Now from here, so how it takes is, it goes to the extreme left item first, like it sorts in this way. It takes the items in this way, extreme right, and it goes in this way and it gets a value. Now that's how it starts from 5, 6, 7 and the extreme left one, right, and gets a value. So we have already seen this sorting in our PGs, right, but this is how tree sort happens internally. Fine. So that is what is tree sort anyways, but tree sort is much faster than compared to the other sorting, so that's why it implements tree sorting internally to the tree set, right. Yeah, so that is how we get. And again this sorting is completely done based on the values you are providing. As we have provided some numbers, right, so it sorted as a number. Now if you make it as a string again, so it will be sorting as per string. So let me take a string here, a simple string. So let me just say same thing. Okay, so I'll take the duplicate values again here. This one, let us say I'm taking I'll take some zebra, okay. So that, yeah, so here it's a string here. So let me, so these items are same again, right? A simple item tree set where we have taken multiple strings here this time, right? We'll see what happens to this when I run this. You see it will be sorted in an alphabetical manner, right? So this is how a tree set works again, right? For all the items. And again, if you create any internal class, if this object is your customized class object, again it takes it takes its own internal arrangement to arrange the objects, right? So maybe all the object buffer will be taken as a consideration and it will be sorting. Now again, tree set always sorts in an ascending order. There is no descending order in tree set. Tree set always arranges item in an ascending order, right? Its own ascending manner. Yeah, so that is something. Yeah, sure.
The way you have shown on Blackboard how the integer gets sorted, can you show it strings?
So strings, it will take the first character and it will take the ASCII number. Again, it is a number sorting, right?
Okay, it will do ASCII, hash code. It will use a hash code.
ASCII, I mean ASCII number. ASCII, yeah.
Okay.
But there may be one thing here. Let us say I have.
First letter, or how does it work?
No, actually it takes the complete one, but see it saves, see, as it saves as if it is a folder. Let us say I'm taking one more thing as $ER, right? Something as dollar, some special character, and I'll take some more things and let us say I'm taking small e, right? Like enum, like something, right? Because ASCII value of capital E and small e are not same, right?
Yeah.
Because they are different. If I run this, right, you can see enum got at the end, right? So dollar is a special character which is lesser than the ASCII values of alphabets, right? With a special character. That's why it got at start, right? And you can see that Apple EAR. So it took the ASCII value of this and it arranged, and you can see enum, I mean small e, got after the capital letters, because capital ASCII value is less than small letters, right? Okay. So it arranges in that way actually, right? So but
in tree set also the unique values are accepted. It doesn't accept duplicate value.
I'm sorry.
The tree set doesn't accept duplicate value.
No, right? Because it won't, because I have given sun 2 times, right? I gave sun here and again sun.
Right?
I'm sorry. Yeah, it'll override this with a new value. Yeah, you're right. Yeah. Okay. If I make it small s, let me make it a small s, right? Now we feel that both are same, right? We feel that both are same, but you can see it's not same, right? As a content part, they are quite different. So it will take the sun and it will keep that, because it is not a unique value, right? So it does a true translation inside and sorts out the data in ascending manner, right, Uchula?
Okay. Yeah.
Okay, fine.
Yep.
So yeah. So any more doubts, guys, here? Okay, fine. So we have seen that we used tree set to sort something, right? To sort some data and all. So you can actually sort. You have a internal method in collection that you can actually sort the items even if it is not a tree set. So you have something called, let me create a new class. Let me take an array list here of maybe integers. So obj dot add of, let us say, 123. Some items. Okay, so yeah, so let us take for each of this item, right, and let me print as L item here. Just out of so these are normal array list which we have seen already, like some list where you can see it will maintain, it won't maintain any sorting, and also it won't maintain any order as such. But for lesser items, obviously we can see that we can see that it is an ordered set, but we know that array list is not an completely ordered set now. So using array list, right, we can do something called sorting. So in collections is a complete util package class dot. We have many internal methods. So among them we have something called sort. So in this sort, just mention your any of the list, right? So what happens is this list will be sorted out. Actually, let me run this again. Now you can see, all the items of your collections are being sorted, right? But here anyways we are actually using the collection class to sort the items of this, right? So let me give some duplicate values here. But again, the main property will not be overridden, which is we know that lists can have duplicate values too, right? You can see duplicate values will be retained, right? So using your collections.sort, you can actually sort the items into items which it has got, right? It is the same case with all the sets and all. You can use the same thing, right? So that is what is complete sets and lists we have seen multiple examples. Now let's move into maps and see what exactly does a map do, right? Now you guys have any doubts across sets and lists, guys? Okay, you can just go through the videos again. If you have anything, we'll discuss in future classes. Fine then. So let me just create a class. Okay, so maps, we have already understood that map is nothing but a key value pair, right? So it is like a lookup table where it can have a key and you can give a value, where a key is something which represents the reference to the value. That is how it goes actually. And anyways, each and every item will be arranged in a separate array manner like this, right? As we have already seen, each and every item. And whenever you want to get something, you have to go and get the value using a key. We will be seeing multiple, what are the different internal methods we have, we'll be using for this, and what is an iteration set we use for this. So now let me take an example of first hash map, how it is done. Again, it's pretty simple. If you understood the collections item, right, it's again a very simple one. E dot get message. So here let me take an hash map. Again, you can see here immediately it gives two things. One is k and v, key and a value. You can actually mention anything as a key, you can mention anything as a value. I can give maybe object here and an object here, which means it can take any value. It can be string, it can be float, it can be double, or it can be anything, right, as a key and as a value. let me take obj is equal to new hash map, right? This is a declaration of a map. This is declaration for all the maps. It can be a linked hash map, it can be hash table, anything. The main declaration will be same. You will be providing two things in here, which is a key and a value pair of these things. If I don't give this, right, you can see it again accepts this. This was there before 5th version of Java, which is before 1.5, right? Actually this restriction was actually introduced from 1.5. We'll understand more how this complete thing works when we actually go to the next topic, which is generics topic after collections, right? We'll see that at that point you will understand this completely, why this is being provided, and this is completely a generic topic. I mean generic topic in the sense the concept generic topic, right? And we can also create our own generics, right? We can also create our own generics using in this pattern. We'll see how we can actually create our own generic, and then you will understand how these things are working inside, right? Yeah. So as of now, let me take it as an object, and we'll see what are the different things we have. Now the first thing is, how can we load data into this map, right? Is we'll be using internal method called put. So when you have hash map.put, right, you have to give two things which is a key and a value, right? Let us say I'm giving key as 1 and value as, let us say, some apple, right? So I just gave this. So this is how you actually insert values into this. And hash map can also have, like we have given it as object, right? Let me take it as hello and a value. Let us say, yeah, I can make this, because key can be anything here, because there is no restriction of a data type here, because I have taken complete object here. Let me take more dot of say 23. And just say some mobile, some data, right? So this is how you actually feed data to the hash map. Now, so feeding data is fine. Now, how to retrieve data? So here, for retrieving data, we'll have to use something called key, so that we can get the value. Now, how to get that is, we have something called obj.get again. So in get, actually it is not that you have to give index, you have to mention your object key or a key value. So let us say I'm giving 1 here, right, which is I have the value of 1. Now let me run this, right? You can see it gets a value of a key. Now let me just take 4 here, which is not there, or 41 here, which is not there. Let me run this. You can see null, but it is not giving an error, right? Because let me just say exception here, and let me run this. You can see it gives direct null, because we are trying to get something which is not there. It will give you a null value. Now before actually getting this, you can have a check again. As we have checked for all collections, you can also check here. You can do two kinds of check. You can check a key contains key or a contains value. Let us say I am checking contains key of 41, right, which is, I said okay, I need a 41 value. Else, let us say I'm just saying data not found, something. Now if I run this, you'll see data not found, because it checks, okay, it doesn't have something called contains key of 41. That's why it skipped. Now contains key of, let us say I'm just taking 23 here, 23 here. Yeah, it will give me the value of my 20. In the same way, you have something called contains value. Contains value will actually check whether that value is here or not, which is, let me take an example of mobile here. Yeah. Contains mobile here, and anyways we are actually getting the mobile thing. If I run this, you can see yes, I'm getting this because it is checking whether a value is there or not. It is there, so we got it. Let us say you are giving some value which is not there. Again it says data not found because it will actually throw you some null. So this is how you actually load the values to the hash maps or a hash map, and you get the values in this way, or you check the values in this way, like contains value or a contains key. Okay, let me just put it in this way so that whenever I copy this file in Dropbox, you will be having a quick view. Let us say contains value, and this is out of contains key of 23. Let us say something like this. If I run this, you can see it is true, 23 is there, mobile MOB is not there, right? So it's false, and here you can see data not found. That is how you work with loading a data and data review. Now here, so let us see how to iterate through maps. Iteration in maps contains a special so one special thing, because here we are not iterating through one set of data, right? Whenever you are getting one set of data, it internally contains two things. One is key and a value, right? So here each and every iteration will give you two things. Now how to get that? So here you have got many ways to how to get that. Okay, so first let me use iterator here. So how can we use iterator? We have something called set. This set will actually give you the complete set of each and every entry set of a map, right? We'll see how. Let me take a set here, like hello which is set, let us say, is equal to, we have something called obj dot entry set. You can see here it will give you the complete entry set of a map. Entry set in the sense each and every data you are entering is called as a entry or a entry set into a hash map. So here what we are trying to do is we are trying to get all the entries of an hash map. Now here again it gets loaded into something called set here, which is an high level set. Now how do we iterate? Use an iterator here, iterator of the object, take it as an object, complete object, and itr is equal to lobj. We know that for complete collection things we have an iterator. Now let me just loop through this iterator again. Looping through is same. You will check whether it has got next or not, right? Yeah, so if it has got next, we do something called itr dot next. Now here the question comes, so whenever we do next, so we know that each and every item is actually getting something called an entry set, but here whenever you get it as an object, it won't give the right value, right? So internally I was talking about some special thing called entry. Each and every entry, how to get that is, you have map dot, you have something called map dot entry. So here you get each and every entry value. Let us say I'm taking it as object, I'm taking it as a, this is whatever I'm doing here is a very crude way of doing, right? We will never do in this way actually, right? Because just to make sure you understand iterator, how it can be applied here, I'm doing this, right? I'll explain you how you can actually directly get this values directly into this, right? Here each and every entry, let us say I'm taking it as entry here, is equal to what next. Now here obviously you have to convert this object into something called entry. Now I have converted into entry, right? Each and every map entry here. But now here you can see entry is an object, entry dot, we have something called get key and a get value. Let me just say this is out of get key plus space entry dot get value, right? So this is how you actually get your entries and all things here. And anyways, you have to typecast it with an entry object. Again, this entry object is again map entry object. You can see there are so many unchecked things, right? It can happen that you may get this as a null. Again, it will give an exception. So I'll give you a right way how to get those things, right? Let me run this once. Right? You can see that you have got, okay, let me just let me draw a pattern so we can understand this. You can see here you're getting a key and a value. Here you are actually iterating through all the values you have, right? So this is how you use iterator to actually iterate through the map. Now let us see the direct element, how actually we can iterate through using entry set directly, right? Now this is something which we'll be using mostly for each. So here we have something called map dot entry. We'll take it as direct entry, right? Which is, we have something called map dot entry. Here we'll take object. We'll take object. Right? Let's say LOBJ. Let us say item, and we want something called entry set. So we know that we have entry set in our object obj dot entry set direct. We got the item directly, which is map entry in for each map entry, because each and every element in our hash map is nothing but an entry. Now that is what I have taken, map dot each entry, and our hash map is completely an object key and object value. That is what we have got. Now let me just print them out, which is LOBJ item dot get key plus some space plus LOBJ item dot get value. It's very simple. Run this, you can see the same output. Okay. So this is how you use something called iterator, and this is how you actually use a direct map, entry map into this, right? So that is how we actually iterate through each and every map item. This map item in this iteration is same for all maps. It can be hash map, hash table, everything, right? We'll be checking out more things in here, right? So that is how you iterate through data. Now here you can have null. You can also have something called nulls. But let us say you have null and some 1 2 3. You can also have that. When I run this, you can see you can have at least one null. If I place one more null of some 4 5, right? Now here, which means I'm actually inserting a duplicate value, right? Which means let me take one more duplicate value here, 23. Again, let us say it's scrapes, right? And let us see. So these two items are a duplicate values. Now let me run this up. Now you can see you have got only one item null, but it actually replaces. Now we have already understood that hash map will always accept only a unique key. It doesn't accept a duplicate keys. But here, even if you actually provide a duplicate value key, it will actually override the new value with the old value. That's why you can see 23 as grapes and not as a mobile, right? Because it is overriding that. In the same way, you can have at least one null in hash map. I'm talking only about hash map. Only in hash map you can have a null, or in linked hash map you can have a null. Not in tree map, not in other things, right? We'll be checking out that. So this is how you actually give the values in here, right? And how it gets overridden with the duplicate values, right? It is same as sets, but here the actual thing happens on key and not the value. You can have any number of nulls, it doesn't matter. Keep null, any number of null values. I mean, you can have null here, you can have null, doesn't matter. It accepts everything. You can see here 23 is null, and null also is a null. Again, null is again a key right here, but actually you can have only one null. Anyways, even if you try to insert one more null, it will override the old one, right? So this is nothing but your hash map, and obviously this hash map will will not be sorted and will not be in an order. So order, it may not maintain order. You can see here, right, whenever I try to enter some more thing, right, one more thing, it overrated and it came to start. But anyway, see, this may not be the right example. Whenever you actually load the bigger sets or bigger data into this, then maybe you will be actually getting the actual difference of ordering of elements, right? So that is something which is a hash map. And hash table, now what is the difference between these two? Both are completely same. Even hash table is not ordered. Hash table will not accept any of unique values. Okay, let me run this once. You can see, okay, so what was the problem here? Okay, let me create a separate program for that, because I don't know what actually we have entered here. Okay, doesn't matter, right? But only difference between a hash table and a hash map is hash table again is a synchronized entity. Hash map and other maps are not synchronized. Only hash table is synchronized. As we have seen something called our string buffer. String buffer is a synchronized one, but string builder is not. So we can say that hash table is something which is a thread safe. Right? Whenever you are actually using a multiple threads, maybe you can go for hash table, which whenever you actually call internal methods of hash table, yes, you will get something called direct values into it. Right? Now, the only difference between these two again is you cannot have hash table, you cannot have a null keyword in hash table. I think that's why it gave an error. Let me just replace again this with the hash table. In hash table here, and let me comment this one and comment this one. Right. Now here we are not giving a null here, right? So run this. Okay, again it is giving null. It is giving null here. Hash table we have. Okay, let me know this complete. Let us give the true data. Yeah, okay. Okay, hash table should not have null, right? So it should not have a null key or a null value here, right? But each and everything, whatever is happening, is a thread safe again. Whenever you say put unless it actually enters the complete data, it will not allow any other item to actually bypass this. It will not. That's why hash table is a thread safe. Again, if you are actually using a single threaded application, never go for hash table, because it will actually hit your performance of your application, right? Because whatsoever you are doing, like getting an entry sets, everything will take some time, right? Because in hash table, because it is a complete, it has to lock this method, it has to get the details, and again it has to unlock this method. So there is some time being taken for each and every internal method operation for a hash table. That is the basic difference. And one more difference was you cannot have a null values in a hash table, but in hash map, yes, you can have a complete null values. That's the basic difference. Now let me take a same example of linked hash map here itself. Linked hash map. Again, linked hash map internally, takes double linked list again. So this double linked list will be created in between these things, like it will be created in this way, right? The same way. Okay? Double linked list between each and every entry, right? And each and every key will be, key and value pair will be locked with the next one, where you'll be having. So again, this contains three memory spaces, one space to store complete data, which is key value, and other space will be for saving next memory, and the previous space will be for saving the previous memory. This is how it saves. and linked hash map can be used when you want to maintain the order of your data input. Right, let me run this. You'll see the same thing, and let me remove these nulls. Okay. I think it should accept that. Yeah, linked hash map accepts this, right? Null. It is same as hash map, but only difference is linked hash map will maintain the order, and it is not the case in hash map. Right? Hash map will actually maintain the data, right? But anyways, if you are going for a lookup table, sometimes you need data to be sorted, I mean to be in order. Sometimes you just need data to be there so that you can just get the value from a key, right?
Srinath, this is
Purush.
Srinath, it will sort, I assume that it will sort based on the value, right?
It will sort? You mean sorting?
Yeah, sorting is based on the value, right?
No, I haven't gone through. Linked hash map will not sort anything, right?
Oh, it is order, right?
It is order, yeah. Order, yeah.
Okay, sorry.
Yeah, and and one more thing is using values, nothing will be done actually. It will not consider for ordering or for sorting anything. Maps will not consider value. It will always consider key. Key is the main guy. Whenever it comes to sorting, key sorting. Whenever it comes to ordering, the ordering as per the key you have entered. That is how it happens, right? That is how you can see here the 23 key was the third place, right? Whenever we gave the duplicate value, it maintained the place. It just replaced the new value mobile with null. That's it. But it will retain the place. Here you can see that all the things are maintained, but it will not sort anything with this value, right? Yeah. So that is something which is a linked hash map. Linked hash map is again same as hash map, and it can accept all the nulls. Right, so that is something which is a linked hash map. Now, the same way you have something called tree map, right? And again, a tree map is something which accepts a unique values, but tree map also should not contain nulls. Let me just create a new class here. So let me copy this code so that we can save some time. Let me remove all these things. Everything will be same. Okay, let's keep that. Tree map, object and object here, right? We just entered everything. It will not accept actually null. Let me just run this up, it will give you, right? Cannot be cast. Let me remove these nulls once. Let us see what happens. Cannot be cast to. Okay, so tree map, okay, it took this hello and it is not able to cast a string. One sec. Okay, so let me give it as a string here. It should convert this to. Okay, oh sorry, we have to convert this integer jar % of something here. Yeah, okay, fine, not a problem. So here in tree map, actually the complete sorting will be done based on key. So there is nothing comes in picture for the value, because value can be anything. It can be multiple nulls or anything, but tree map will never accept something called null. But let us say your value here is null, right? Let me run this. You can see it accepts null, but only at the value place, but not in the key place. It won't accept. Let me just remove this part, right? Exception null. It won't allow null as a key, right? It always allows this. And anyways, the key in tree map should be a finite value again, right? It will not take infinite value. Like it will not take the string, which is it is not a definite value here. That's why it gives something like exception, right? So that's why here you have to maintain a tree map, and you have to at least, if you want to be make it sorted, you can see the sorting is made completely on the key, right? So that is how the tree map works. Yeah.
So a tree map would only take numeric strings once it's parsed. When you call a parse integer method, it won't take a regular letter string. Right?
Yeah, it won't take, because it has to. It will convert the key to the true translation. Let me take it as $, right? Let me take it as $, but here itself it is gone, right? Here itself it says it is not string. So even in string, it should be a finite number, right? So that you can convert it. Right, Ron?
Okay.
Yeah. Tree map will not allow nulls. Tree map will not allow infinite, or it will allow only finite values, right? Which is your key always should be a number or a float. Let me give float value 1.6 here. Let me run this. Okay, again it should be cast to number again. Okay. Oh, again there is a restriction in 1.7, it seems. Parse in 1.6, let us say. Run this. Okay. Or let me typecast this one. Why can't I? I cannot use any string here, so it is converting this. Okay, anyways, 1.6 got converted again to integer. Yep, we should take only integers, wrong, right? Yeah, you should take only, it should be only the integer type in order to make the sorting, right? Yeah, and again internally the tree map again takes all the keys, and it will actually form the sorting in that way. One sec, let me just convert it to string once, and let us see what happens here. So there is a problem with end reset, right? Yeah, I have to make it string. Okay, again it thrown error. Yeah, so yeah, confirm. So this will take only numbers, it won't take string. Even if it is a string, you have to make sure that it is converted to string at least. Integer dot parsing. But it will not accept a string again, right? Which is 135. Let me take this. Some integer here. Yeah,
I think that's a little bit odd, because it accepts a string as a key in your declaration, and when you're
yeah, actually, yeah, even
allows you to.
Even I am surprised actually. Yeah, that's why it should actually take the complete key, and it should sort actually making that. Yeah, so yeah, it should, but I don't know. I know. Let me just trace to this, because I've seen sometime that it before that tree map will actually take a complete true translation of tree sorting, and it will actually sort. Okay, let me give some glance on this again. Okay, yeah, but as of now you can see that it is taking only integer, right? I'm trying different combinations here, but it is taking only integer. Okay, let me just go through some API documentation, and let me see whether it is only confined to integer or not, right? Okay, but the thing is tree map will always sort using only key, right? And key here it is taking complete integer as of now. Let me check this out for other things, and I'll give you a clear explanation on after reading out the API release document. Fine, I'll give you that explanation. Fine guys, so this is tree map which we have. Again, it is using internally a sorted map, which is tree map implements sorted map interface again, right? As we have seen something in sorted set. Sorted set is an interface which is being implemented by a tree set, but we have seen something called in tree set. Everything it got accepted, everything, right? It accepted integers, strings, and everything. But here let me check this out, okay, and we'll give you more glance on this. Fine guys, so that is all about our collections we have, right? And that is maps and iterators which we have, and get entry sets and all, right? And you have one more thing in here, which is, let me just copy this, and obviously you will not use this much, but for each, let me take it as string of lstr key, let us say, right? You have something called obj.keyset. Yep, okay, keyset here. So keyset again will give you each and every key over here actually, right? Keyset, yeah, no issues. Let me just say obj dot your keyset. Again, you have to take it in a subset here. Set, let us say L keys, it's equal to key set, right? So here you can write for each object in key, right? Now this object is nothing but a key. Let us say okay, let me give it as L obj key here. Now this will give you directly, which is obj key plus some space, and you can see here obj dot get value of your object. Now here object is nothing but your LOBJ key, right? You can actually do this. Let me run this. Now you can see the same pattern here, right? Yeah, you can see the same pattern where you're actually iterating through the key using key set. Yeah, you can get all the keys. You are actually iterating through the key, and you're getting the value, right? So there is one more option to actually iterate through the hash maps, and this key set option is same for all. It is same for all the maps, right? You can use key set for any of the map where you're actually getting the key set of the map. Fine. Yeah, so that is all about map collections guys. So I hope you have a bunch of programs. So I'll be sharing this video again, just go through everything, okay? So tomorrow we'll see generics. First we'll check out what is a generic. It's a very easy topic, but it all depends where you'll be using generics, because generics most of the people don't use, and some people mostly use generics. Yeah, and all these collections, the restriction of collections, which is this part, is actually being introduced after introducing generics topic, right? You can also create your own class where you can actually restrict some data type, right? We'll see how to do those things, and different topics like static import, what is variable arguments, everything tomorrow, right? And maybe probably our first hour we'll see that, and after that we'll start with the GUI part, right, with some AWT and all. Fine. So any doubts across, just
same time tomorrow.
Yeah, we'll meet the same time tomorrow, and maybe I'll take 2 hours tomorrow, right? And I think if this weekend is possible, just let me know tomorrow, if possible, right? If even if one day is possible, that's fine. I just want to get some more time. That's a reason, right? Okay. So because by next week we have to complete. Anyways, we'll be completing this by at least by Wednesday, or probably by Thursday, right? We'll be completing. So the tomorrow we'll be having 2 hours, but let me know when, if it is possible for this weekend. Fine, guys. Okay then.
Srinath, Ujjwala.
Yeah, Ujjwala.
Just one request, if you can give us some exercise problems to do on our own.
Okay,
weekly
so
ones or daily.
okay, you want
That way we can work on it. Otherwise, it's just like we are learning the things, but it's not where we can apply the knowledge.
okay, fine then. So let me give you some use
Then
cases.
it will be like comparison will be there, like we can,
Definitely. I'll give you the use cases. Okay, so let me prepare use cases for the complete core Java, right? So that I'll just get some good examples. Okay, I'll give you that simple examples of core Java, right?
Okay.
Multi-threading files.
And you'll upload that along with the list of the curriculum, right?
Yep. I'll be uploading that today. Yeah, I'll do that.
Good. All right. Thank you.
Okay.
Thank you.
Okay.
Thank you.
Guys. Okay, fine. I'll see you tomorrow then. Bye bye.
Have a good day. All right. Bye bye.
Bye bye.
Bye.